Hello and welcome to Minikun Tutorials. In today's tutorial, I'm going to show you how to change number of decimal places or digits for column values in R or RStudio. Okay, but our tutorial will not just be limited to changing number of decimal places or digits for column values, but we would also look at, first of all, how we can actually round up or change the number of digits or decimal places of a single figure like 662.54367, okay, or how we can actually even round up a single decimal or figure like this particular one to the nearest whole number, okay. And then gradually we also look at how we can actually round up several values of a given vector to a specific number of decimal places, or even to the nearest whole numbers or whatever, okay. And then gradually we graduate to looking at how we can actually round up values of a particular numeric variable or column within our data set or data frame, okay, into specific number of decimal places. And among the examples that we look under, let's say, rounding up values within a data frame or data set, we actually look at finally how we can actually break down or simplify large values or figures. I'm saying this for a reason. For instance, if you have a column of, let's say, a column named amount, okay, then you have like 80 million, 50 million, and whatever. Whenever you have such large figures and R doesn't have enough space to present it the way it is, so what R does is it often writes it as, let's say, for example, if you have 18 million, R would write it as 1.8 times 10 to the power maybe 6, okay, or to the power 7 or whatever. So if you don't want some of these things to be occurring, then you have to make sure you could create a new column that you would title, let's say, amount underscore million. Then instead of writing 18 million in full, you would instruct R to just write 18. If it's 15 million, write 15. But everybody knows that this column is 15 million, is in millions, right? In that case, million becomes more or less like a unit for your column, just to prevent you from writing things in full. So there are a lot that we can actually do when it comes to this particular topic, and please remember to subscribe and turn on the notification bell in order not to miss future interesting tutorials like this particular one. So without much ado, let's start first of all by looking at how we can actually round up a figure to a specific number of decimal places or even to the nearest whole number. Now we have A here as a figure, okay, so we have the figure is actually 662.54367, and I've saved it in an object called A, so that anytime I want to write this figure, I simply write A and I'm good to go. So if I should run this particular code and I just type A here and hit enter, you would notice that by default R is able to present up to 4 decimal places, okay. So we have 662.5437, and you would say, why would it round it up to just 4 decimal places, meanwhile the original figure had 5 decimal places? So how do we instruct R? So this is just a good start. How do we instruct R to actually give us the full figure? Okay, how do we do that? It's very simple. So to do that, so we actually going to tell R to present this particular figure in 5 decimal places and not 4 decimal places as it does it by default. So let's assume that our new figure, we would call it B, okay, B in 5 decimal places, just as the original figure, but we want it to be presented as it is, the original figure, which is this, and not in 4 decimal places as R by default presents it. So we'll say b, for instance, which is an object, you say equal to, or you say less than, and then hyphen. Then we use the command, let's say format. So we say format, we open bracket, and then we say round. Okay, now we open bracket and we have to round the figure A. We specify the number of digits after the decimal point. Okay, so we have to specify the number of digits after the decimal point. If we want this particular figure, since we want it in full, then we have to say that we want R to present this figure in 5 digits after the decimal point. So we have to indicate that digits here is equal to 5. Then we close the bracket, and then if we are telling R that the number of digits is supposed to be 5, then we have to also indicate that the number of decimal places must also be 5 for us to have the 5 decimal places. In case we want 6 decimal places, then we have to indicate R that number of decimal places will be equal to 6. So how do you specify the number of decimal places? Now, in a case where we tell R that we want the number of decimal places to be 6, it means since the original figure only has 5 digits after the decimal point, R will be forced to put 0 here, though the 0 will not make any change, but we put 0 just for us to have 6 decimal places. So how do you specify the number of decimal places? So to specify the number of decimal places, we say n small is equal to, n small is for the number of, specifying the number of decimal places. So if I say n small is equal to, let's say 5, it means we're gonna have 5 digits after the decimal point and then 5 decimal places as well. Now I'll simply close the brackets. Okay, and if I should run this, let's see what we will get. Sorry, let me run it again. Okay, now if I should say B and hit enter, you see that R has now given us the figure in its original form, which means in 5 decimal places. Now let's say for instance we wanted 6 decimal places. So we want, let's say let's assume we still want 5 digits after the decimal point, but we want 6 decimal places. Like I said, what we simply have to tell R to do is to put an extra 0 so that we can have 6 decimal places. It's just a way of presenting things. I don't know whether this will be necessary in real life, but what we are doing here, the purpose for rounding single figures is just for you to grasp the concept, so that when we move on to data frames, you'll be able to apply this very well. So I'll simply copy and paste this. So let me paste it here. Okay, and after pasting, if I should say n small is equal to 6, remember I said n small is to specify the number of decimal places. So if I should say n small is equal to 6, it means since we have 5 digits here, which is digits equal to 5, R will be forced to put 0 so we can have 6 digits. N small is for the digits. So if I should run this, if I should hit B and enter, notice what I said, 0 has been added. Now let's assume for instance we wanted the figure in 2 digits. Okay, so we wanted to round this particular figure to 2 decimal places, in other words 2 digits after the decimal point. Then it's just simple. You just, let me copy this figure again, oh sorry, this code again. Let me simply paste it here, and after pasting I'll just simply say number of digits here is equal to, let's say 2, meaning it will be 662.54. and that is just it. Then I'll say n small is also equal to 2. Alright, let's run this. If I should hit B and enter, okay, look at it. In case I want to say, for instance, I want the number of digits to be let's say 2, however I want 1 0 to be added, now of 2 0 to be added, so it'll be 4 decimal places but with 2 digits, so it'll be 5400. Then I have to put the number of decimal places to be what? 4. If I say the number of decimal places, which is n small, to be 4, meanwhile I'm saying the number of digits to be 2, then we have 0.54. R is forced to add 2 additional zeros just to give us the 4 decimal places, though those zeros are not going to change anything as far as the value of the figure is concerned. So if I should run this, and then once again I hit B, enter, you see what I'm saying. Now let me not waste my time on this. Let's look at how you can actually round this figure to the nearest whole number. Now to round this figure to the nearest whole number, as usual, let me copy the code again and I'll paste it here. And since I want to round 662.54367 to the nearest whole number, it means running this to the nearest whole number means we're gonna have 663, right? So how do we do that? Then we have to indicate that we don't want any zeros after the decimal point, any digits after the decimal point. In other words, digits will be equal to 0, and at the same time we don't want any decimal places, so this too has to be 0. Then R will be left with no choice than to give us the nearest whole number, so 662, but this is up to 5 at least, so this 2 here becomes 1, so it'll be 663. To prove this, let me run this code. If I should hit B and enter, you have 663 here. So this is how you can also round your decimal to the nearest whole number. Now let's move on to vectors. With regards to vectors, it means we have several we have several values that we are interested in within our vector that we are interested in. These values are actually concatenated by the code C here, which is to concatenate all these values into a single vector, and we are interested in rounding or changing the decimal places of all these values to a specific number of decimal places. So let's assume we want to change all of this to 3 decimal places. How do we do that? To do this, we will have to use the for loop, and after which I will show you another option in the case where you want to save your results. If you want to save your results in a particular object, then you will have to use the if else command. So how do we do this? First of all, so we will use the for loop like I said, and then we simply say let's say you use the for, then you open bracket and say I in A, for instance. First of all, let me run this first. The vector is here, so let's run it. Okay, if I say A and enter here, now look at our vector here, no error given, perfect. Now we're going to use our for loop to round all these values here to, let's say, 3 decimal places or 2 decimal places. How do we do that? So we say for I in A, then we close the bracket and open. So this is a condition. I here is an integer, so we are saying that for I in A means I can take any of these values. Okay, any of these values within A. Now we have to specify the instruction, right? Or we have to give the instruction. So we say print, then we open brackets, then we say format. It's just the same principle. So we say format then we open brackets, then we say round. So we are saying R should round what? Then we open brackets, we put I, which means it could be any of these values that R is going to round. Then we put a number of digits. So digits is equal to what? We want it in 3 digits, right? So if we want it in 3 digits, so or 3 decimal places, then we say digits will be 3 here. We close it, close the bracket, then we put n small to indicate the number of decimal places to be also be equal to what? 3. Okay, now let's close the brackets. Remember, we have format here, so format is well closed. Yes, format is well format. No, we have format here, opening bracket, round here. Okay, yes, format is well closed, but print needs to be closed, so we need to add another bracket, and then we close the curly bracket. And if I should run this, now see what happens. So you see that all our 4 figures within this vector have been presented in our 3 decimal places. If we wanted it in 2 decimal places, if we wanted to round it to the nearest whatever whole number, then it's just the same principle. So let's assume we want to round it to the nearest whole number quickly. You just copy the whole of this, you paste it. Let's paste it here. If I want to round it to the nearest whole number, then I simply have to indicate the number of digits after the decimal point is 0, number of decimal places to also be 0. If I should run this, then there we go. We have it to the nearest what? Whole number. It's just simple. But now let's say we want to actually save. Remember that when you are using a for loop, your results are not going to be saved in any object. So, and you cannot have a situation where if you want to cite or state, I mean, let's say the rounded values here, you don't have to put this long code. No. So to prevent this, you have to devise a means of saving your results in an object. So if you want it that way, then you have to use the if else command. Maybe there are alternative methods, but that's what I think is I know for now. So I would say, for instance, B, supposing B is another object that we're gonna give for, let's say B will be a vector which will comprise of what? All these rounded values in 3 decimal places. So we say B here, then we say either equal to, okay, so we say B is equal to, or use less than, and then this is the same, and hyphen is the same thing. B is equal to, sorry, then we say B is equal to what? Then we use the if else command. So if else, we open brackets, and then we say if else, we are saying if else the vector A, we put comma. Okay, so what I'm trying to say is that if we have the vector A, then what will be the condition? Let me just copy this part, for instance. So the if else command, we are saying that if we have the vector A, then the condition, the yes response is that then put simply round of this all the elements within A to a particular decimal place, or even to the nearest whole number. So let me just copy this part in order not to waste time. So we just say if this, if the vector A, then simply let me copy this. If the vector A, comma, and paste this. Format into brackets round A here. Number of digits should be what? Into 3 digits, and small is also equal to 3. So we have format, bracket open, this is okay. I think this is perfect, but the if else would need another bracket. But before that, okay, yeah, before that you have to also put a condition. In the opposite round, what will be the results if not A? Let me just say, just still put A. It's just nothing. Okay, the no response is still the same. I'm saying because I know A stands for all of this, there's no exception. This is the vector A. So, but it's mandatory if you are using the if else command to put the no response. So you're saying if A, this is the condition, format A into 3 digits with 3 decimal places. If no, still put the value of A. But I know it's not going to put the value of A because all these values are actually A's. So it's just a trick. So A here, format into brackets round into brackets A, comma digits is equal to 3. So format, the bracket is closed, but our if else we will need another bracket. Okay, so let me run this and you see what happens. Now if I should say B and enter, notice what happens. Our vector, we now have it in what? 3 decimal places. And we have our object here, which means anytime we want A in 3 decimal places, we just type the vector B and that is it. We don't have to write everything. So I think the procedure is pretty much simple, and we have to move on to something else. Okay, so let's move on to data frame, and then we're going to look at how we can actually apply this concept, because that is the most important thing. In real life, you are not going to work with single figures. You always be dealing with data. So when you read your data set into R, having understood this concept, when you read your data set into R, how can you, for instance, round or change decimal places or digits in a particular variable or column of your data set? So to do this, let's assume I read this data set into R. If you have problems with reading data set into R, check in my channel and you find several videos on that. So this is the code. It's a CSV file. It's on my desktop and I'm going to read it into R. So let me just select the whole thing and I run it. And if I should say print into brackets data, just to show you the data. So print into brackets data, let me run this. And then we have our data set here. So let's assume it's a data set of comprising of 14 patients. We have the patient ID, gender, age, weight, body weight, diagnostic status, and then the year of birth, for instance. And let's assume we are interested in, let's say, rounding weight of patients to the nearest, let's say, to the nearest, let's say we are interested in rounding the weight of patients to the nearest whole number. Okay, let's say instead of having 20.5, 20 point this, we just want to round it to the nearest whole number. So we have the ages of the patients to be 20, for instance, 21 for the first patient, 28 for the second patient, 25 for the second patient, 28 in that order, 25 for the sixth patient in that order. How do we do that? It's very simple. It's up to you. Okay, you have the choice. The question is, do you want to create a new variable or a new column within your data set, or you just want to change the existing variable? So first of all, let's assume we want to change the existing variable, which is weight, into the nearest whole number. How do we do that? So to do that, we simply use let me get down here. So I'll simply say data here, then I use the $sign to select the variable in question. The variable here is what? Weight. So data $sign weight. Then we use either equal sign or you put less than and then hyphen is the same thing. And then we would say we're gonna round this to the nearest whole number, right? So we say this is equal to format, and we open brackets and say round into brackets data $sign weight. Okay, then we put comma and we have to specify the number of digits. So since we want to actually round this to the nearest whole number, so we have to say digits is equal to 0, which means number of digits after decimal point will be 0. Then we close the brackets, put comma, specify the number of decimal places. Remember we want to round the weights of these patients, which is the whole of this particular column. We want to round it to the nearest whole number. We don't want these decimals. So we have to also indicate that n small, which stands for the number of decimal places, n small will also be equal to 0. Now if I should close the brackets, I think we are good to go. Perfect, yeah. So let's run this and see the magic. If I should run this, okay, now if I should say print data, just for us to see our data set, let's see what we've got. Okay, you realize that the weight of patients has been rounded, okay, to the nearest whole number. But you may say, no, but Minukum, I'm not interested in changing the original variable. I would like to create a new variable within my data set. It's very simple. If you want to maintain the original variable weight with these decimals and you want to create a new variable, it's very simple. In this case, read your data set once again to do away with the changes that we've done to the variable weight. So I'll simply read the data set again. Let me select it and read it into R. Okay, and once it's read, if I should print data, you realize that my data set comes with what? In its original form. The weight, the variable weight hasn't been rounded to the nearest whole number. Now let's assume I want to create a new variable. So let me just copy this code and paste it, and I'll just do the modification. So I'm going to create a new variable. Now this new variable we call weight rounded. So once I say data $sign weight, means you have to create a variable. If the variable already exists, then I will not create a new variable. That's why when I did it the first time, remember, it's the same thing that I repeated here. But in case you want to create a new variable, then you have to indicate the name of the variable, the new variable. So we'll put weight rounded to the nearest decimal, to the nearest whole number. So rounded. If I should run this, perfect. Now if I should print our data set again, notice what happened. So we still have our weight here, and a new variable has been created, which is weight rounded. Okay, and then we have our weight in the nearest, or to the nearest, rounded to the nearest whole numbers. So this is simple. If you want to round this to 3 decimal places, kindly apply the same principle that I showed you. If you want it in 3 decimal places, let's simply copy this and paste it here. In case you want weight rounded let's say into the through 3 decimal places, then you just simply put number of digits to be 3, meaning number of digits after the decimal point will be 3. Number of decimal places, which is n small, then you also put 3, and that is it. If I should run this, let's print our data again, and you see the magic. You can actually create several variables by what I'm showing you. So you see that it's rounded to 3 decimal places, and this is how you can actually round figures to the nearest decimal places or whatever in your data's frame or within a particular numeric variable or column of your data frame. The second example that we will look at is how you can actually add some extra zeros. Now, what do I mean by adding some extra zeros? Just like what we looked at earlier on. If you have whole numbers, let's assume for instance you have the age of patients, which is 10, 11. This is not in decimals, but you want to just introduce some zeros. You don't want to write it as 10, 11 and that order. You want to write it as 10 point something, 11 point something. How do you do that? It's very simple. Let me copy this code again. Okay, let me copy this code in order not to waste time. Okay, let me copy this one and just edit it. So I'm going to create a new variable which is still weight rounded. I'm not actually going to create a new variable. It's still the same variable that we have already created, weight rounded, and I just want to change it to I want to round it. No, sorry, here we are not talking about weight. Let's assume we want the h here, so it will rather be h rounded. Okay, but there's no need. We just want h the way it is, but with 0.00, 0.00. So we want to introduce some fake decimals there. Okay, so we say h here. So the variable that we are selecting is h, or we are creating is h. Here too would be h. So we are saying that please format this particular variable. We don't want any digits after the point. Okay, so we want to round it to the nearest whole number. However, we want some zeros. So by adding any zeros here means that if we say 0.00, it signifies 3 decimal places. If you say 0.000, it signifies 3 decimal places. If you say 0.00, it signifies 2 decimal places. If we say 0.00000 in that order. So we want 2 decimal places, but we don't want any digits. So it will be rounded to the nearest whole number, but with point something. In actual sense, it wasn't even a decimal, so it's not like it's rounded. We just want to add point something. So we just put here number of digits will be equal to what? 0. Number of decimal places, which is n small, we put 2.00, and that is just it. If I should run this, perfect. Now if I should print our h again, or data, sorry, you see that h is now what? 0.00. So that's just it. Now let's move on to the last part, which has to do with, like I said, simplifying large figures. So for this example, I have another data set on the desktop that is called effects19. It's a CSV file, and I'll just read it into R. It's well read. It's a very large data set, so if I should say print data, print into brackets data, let's see what it contains. Since it's a large data set, I cannot show you everything. You see, not everything will display, it's too large. So we usually use the command head just to show the first 5 rows of your data. So head into brackets data here. If I should run it, you have your data set, the first 5. Okay, and now what can we say here? If you want the first 10, then you say head. Yes, you could have said print into brackets data, then you put n here equal to, let's say, first 10. So print, you just put 10 here. It will show you the first 10. No, sorry, I think it's in head. Sorry, I'm so sorry about that. It's in head that you have to put comma, then you say n is equal to 10, meaning it should show you the first 10 rows. But if you just say head, by default it will show you only the first 5. Okay, now as you can see our data set, we have, for instance, value here, the variable value or the column value. As I said, it has a lot of long figures. It's like 6 figures, right? So we have 96 million, 104 million, in that order. Assuming we don't want it this way, we want to create another variable which is called value underscore million, and then we just want R to put 104, 96, 61, in that order. How do we do that? It's very simple. First of all, assuming we don't want to even, okay, let's do that. Let me show you how we can do that quickly. So first of all, anytime you read data into R, always use the str command. So use str into brackets data. This shows you the nature of your variables. So if I should run this, let's look at the variable value. It's an integer. Perfect. Just to confirm that all integers or whatever, all numeric variables are recognized as numeric variables, or integers, which is the same, and all categorical or qualitative variables are recognized as either factors or characters. That's why I showed you this str command. It wasn't necessary, but it was just a bonus. Now if we are interested in actually breaking down or simplifying the variable value into let's say, I don't know how to call it, we don't want to have 104 million, we want to just have 104. Then it's also very simple. We can simply say our data here, then we use the $sign to select what? Value. In the case where we want to create a new variable, then we have to edit the original variable name. If not, if we want to just apply the changes to the existing variable, then we don't have to do that, but I would prefer we create a new variable. So we say $sign value underscore, let's say, million. Okay, and then what will we do? We say is equal to, and then we'll say, for instance, data $sign value, which is the original variable that we are selecting. If we should divide this particular variable by, let's say, a million, so 1 1 2 3 1 2 3 6 zeros, let's see what happens. Now if I should print our data set again, as usual, like I told you, the data is too much, so we cannot, so we just show the first 10 people, for instance. And you see that a new variable has been created, and this new variable is now what? Value million. Then we have 104, 96, in that order. Let's assume we want to put this into a number of decimal places. I don't know what, it's still the same principle. If you want it in some form of decimal places, then you can simply repeat what I showed you earlier on. If you want to have some point zero zeros or point whatever, this is the time for you to do that. Let's just copy this code here in order not to waste time. Okay, let's assume I want to put some point zero zeros. Simply copy this code and come and paste it here. And here we have our data. Let me just copy and paste so that we don't waste time, like I said. So I'll replace this. This is what data value million, okay, to equal to data $sign. Then we put here will be what, value, which is the original variable. Now we want digits is equal to 0, but we want 0.00, so number of n small or number of decimal places will be equal to 2. If I should run this, but I actually have to be careful here, because once I do this, yeah, this is data. If I wanted it, then I have to say over million, okay, over 1 2 3 4 5 6. If not, I could have just stated, since this variable is already created, I could have just kept data $sign value underscore million, since the variable is already created. But assume the variable wasn't created, then I have to say data $sign value underscore million, which is a new variable, is equal to format round into brackets data $sign value divided by a million. Then we put comma, we specify the number of digits, which is 0. We don't want any digits after the decimal point. And then we are saying that number of decimal places, which is n small, is equal to 2, meaning I will be forced to put 2 zeros. And let's run this and let's see magic. I think I'm missing something. I'm missing something. I don't know what it is, but I'm missing something. I needed another bracket, so let me just put a bracket and hit enter. Now what I simply did, I was supposed to put a bracket here. I didn't do that to close. That's how it's supposed to be, to close the format bracket here. Now if we should print our data set, it's too much, so as usual we just print the first 10, and you see the magic. Thank you so much for watching, and please subscribe.